Hello, my name is Alejandro Torres, and I'm going to present my research to you, which is titled Oxycodone-Induced Dependence Modifies BDNF Levels Within the Frontocerebellar Circuitry in Adult Male Rats. In the United States, the opioid crisis has caused pathology, loss, and disability. Addiction to prescription opioids such as oxycodone, a mu-opioid receptor agonist, is present a public health issue as being one of the most widely distributed and abused opioids. The cerebellum is a structure known for motor control and balance. Recent studies suppose the involvement of the cerebellum in addiction, as it might be related to reward-seeking and motivational drive. Mu-opioid receptors are expressed in the cerebellum, and yet the effects of oxycodone in the cerebellum remain unknown. Brain-derived neurotrophic factor, or BDNF, is believed to regulate opioid-induced plasticity in the mature brain and promote cell survival, proliferation, and apoptosis. Here, for the first time, we aim to investigate the effects of induced opioid addiction on endogenous levels of BDNF from the cerebellar vermis and the prefrontal cortex. We hypothesize that the levels of BDNF will decrease in oxycodone-treated animals, and that oxycodone-seeking behavior will modify the levels of BDNF in the cerebellum. For experiments, we use in vivo model comprising of adult spragging male rats and the conditional place preference paradigm. After oxycodone conditional place preference, we extracted the brains, and then we dissected into the cerebellum and the forebrain to obtain the prefrontal cortex. Then we homogenize the tissues and prepare them for analysis of protein. Then we run an BCA assay to obtain the optimal dilution concentration before we analyze the BDNF content. Then we use an ELISA to detect for the presence of pro and mature BDNF. Here, in this graph, we're expressing the results from the conditional place preference test, and the control group displayed that they spend the same amount of time in either side of the chambers, while the oxycodone-treated animals significantly spend more time on the drug per chamber, which indicates that they develop a preference for oxycodone. Also, for the cerebellum, the pro-BDNF was seen to decrease on the oxycodone-treated animals, and also for the mature BDNF levels had decreased in comparison to the control groups. And in the prefrontal cortex, we saw a different result since the levels of pro-BDNF actually increased for the oxycodone-treated animals, but the levels of mature BDNF decrease on the oxycodone-treated animals in comparison to the controls. In summary, oxycodone conditional place preference modified BDNF levels in a seesaw-like mechanism in the cerebellar vermis and the prefrontal cortex. The cerebellum seems to have much more abundance of mature BDNF, and this could be linked to a difference of mu-opioid receptors. In the future, we would like to investigate whether adverse childhood experiences and early stressful events influence the onset of oxycodone preference and the endogenous levels of BDNF in adolescent rats. And we would like to evaluate the relationship between the levels of pro-BDNF and mature BDNF from hippocampal regions in the brain.